Assalamualaikum and a very good day to everyone. My name is Mohamad Akmal bin Muhammad Nizam, and today I'll be presenting my PSM2 project titled Real-Time Face-Spoofing Detection and Attendance Management System for Educational Environments. This project is supervised by my doctor, Associate Professor Dr. Nur Azman Ismail. So the outline of the chapter of the presentation is we have chapter 1, Introduction, chapter 2, Literature Review, chapter 3, System Development and Methodology, chapter 4, System Design, chapter 5, Result Testing and Discussion, and chapter 6, Conclusion. So the chosen stakeholder for this project will be University Technology Malaysia, which is UTM. Alright, so let's proceed to chapter 1, Problem Background. One of the problems with the current attendance system is that there is problems with QR code attendance. QR codes can be scanned anywhere, making them susceptible to spoofing and fraudulent attendance marking. Second is operational inefficiencies. Manual and QR code based systems require significant administrative effort, are not scalable for large institutions. And finally, challenges with face recognition technology. Effective spoofing detection algorithms are essential to ensure reliable and secure face recognition based attendance system. So, the aim of this project is to develop a secure and efficient face spoofing detection and attendance system that leverages advanced face recognition technology and machine learning algorithms for accurate attendance tracking in educational institutions. Right, so let's move on to the project objectives of my project. First of all, is to identify the elements and features of real-time face detection for class attendance systems. Second is to develop a real-time web-based application for face spoofing detection and attendance management in educational environments based on a machine learning approach. And the last one is to evaluate the effectiveness of the developed system in a real-time attendance recording. The system will be developed as a web-based face spoofing detection and attendance system. The second is that the user categorized within the project scope will include students and faculty members within educational institutions. Especially, I'm targeting for the stakeholders as UTM, where the students will use the system to mark their attendance, while faculty members will manage attendance records. And the last one is the primary focus of the system will be on implementing anti spoofing measures to ensure the recognition of genuine live faces, where emphasis will be placed on preventing unauthorized access and minimizing false positive during attendance recording. Let's move on to comparison between algorithms. There are three algorithms that can be used in the anti spoofing feature. The three algorithms are deep learning, which is CNN, eigenface, and fish face. So one of the advantages of using CNN is it captures intricate patterns effectively adaptable to diverse datasets. The disadvantages is computationally intensive and requires substantial resources for training. Second is the eigenphase, which is efficient dimensional reduction, very suitable under control conditions. It may lack discriminative power for subtle facial differences. And the last one is fish face. The advantage is it incorporates FLDA for enhanced discriminative capability, and the disadvantage is it may struggle with adaptability to complex facial patterns compared to deep learning CNNs. So one of the algorithms that I choose in this system is using the CNN network, which is the YOLO network. So for this system, I will be using the Agile Waterfall hybrid methodology. Here are the tools and technology used to develop my system. I use YOLO VN to use as a machine learning model and train my data sets for the anti-spoofing feature. I'll be using Firebase for the database for the face recognition system. And also use the MySQL database for the users system. I will also be using Laravel PHP for the backend, and I will be using Tailwind CSS for the front end. And I'll have two IDEs that I'll be using, which is PyCharm and PHP Storm. Here is the use case diagram for my project. The actors are admins, students, and lecturers, and we'll be having 7 use cases for the system. For the project design, I will be using Model View Control MVC architecture, which is already I'll be using inside the Laravel PHP framework. So here is the project design, as you can see here. Now I'll be showing how the system works in the next video. So 0 is for fake and 1 is for real data. So now let's run data collection, and now it will detect my face, and every time we detect my face, it will collect the data of my face. So see, you can see here it's collecting all the data of my face. After collecting the data, and then we will go to the data collect. So inside here we'll store my images. There we go. It also store like the coordinates for the machine links to identify which is the middle ground. So after that, we select all of the data and the coordinates of the images. I have to select few because I have to determine how many. We have to make sure that the fake and the real images is balanced, so we can train the data equally. So now we paste data inside the all. So you can see inside here we finish, and now we will run to data collection number 2, which is a fake. We try to collect fake data, which is spoofing data. So here we go. I'm collecting using my iPad over here. So then after we've collected all data and put inside the all folder, we have to split the data. So paste inside the all folder. So that's what I said from the coordinates. And now we run split data. We try to split all of the data. So we have a data.yml file that's been created. So inside the split data, so as you can see here, are the data has been splitted for the training model. So we have to split the data first before we train the model, so we can know which one is real or which one is spoofing. So here is it on the data again. After that we finish, we have to copy the data.yml file and we have to paste it inside the split data as a data offline, because we want to train the data offline. Since we want to train it inside the machine, so I'm using my machine. We have to copy the absolute path inside the data offline.yml file. We have to paste inside the path, and we have to delete some file of it. We delete that one, and then after that we have to go to the train.py. So now we have to run the train.py. We run into the data offline YAML file. So here after we have finished the training, so we're running the training right now. Yeah. So now after we finish the training, you can see this is all of the data that has been trained using the YOLO v5 a model. It's an architecture. So now let's run the test anti-spoofing to test the feature after I insert the model. As you can see, it can be detect the real, and that's my face is detecting real. So now I'm grabbing an object to detect as a fake. So I'm grabbing my iPad over there to detect as a fake. So I've trained a lot of data using my data sets. So there we go. It's detecting real and fake. Currently it's not really accurate because the amount of data that I have is not much. So I have to train a lot more data to make sure it's detected much more accurately. So now I'm running the main feature, which is now is downloading the images from the database. After download the image from the database, it will put into an array. So inside the array, we encode each images to detect who is the person. So each image has its own encoding. So let's see, I have my own images. It'll be encoded with myself. So as you can see, I'm trying to detect my face over here. So it takes some time. So now it detected my face. Now I'm grabbing another model, which is my phone. So inside this system, we detect an attendance system over here. So every time it's record the data, my attendance will update to the latest date and time. Also record the attendance time. So here you can see the recording again. Data will be updated to the latest time. My project PSM2. So this is a sign-in page for the lecturer. The lecturer can only log in. Only the admin can register the lecturer. So let's sign in. Already registered an account. So let's sign in. So when we get to the page, we get into the edit profile page, which is the basic home page. I can change the home page, but let's put it inside the main home page. So let's say Akmal here edit profile. I will say Akmal Pandai. I say Akmal Pandai. Let's update the phone number 017 Okay. And we update the profile. Profile updated successfully. We go to the database. You can see the name we call Akmal Pandai, and the phone number will change to 01766 as you can see there. So we go back to the system. We go home. The home, this home will actually display the student record. So right now I only have my images inside my system, my computer right now. So this is the registered users. So we go to the student. Here's the database inside of the storage account. So you see the Firebase. So the image URL, when we search for the image URL, we will display the image that we have transferred into the database. So let's go to register student to demonstrate how the lecturer can register the student. Let's say I want to register Elon Musk. Any metric number, just input the metric number. Electrical engineering from class, any class. So student year, first for search for student year. At the starting year, 3, Elon Musk graduate.com. So I don't have any picture of Elon Musk. Let's use my picture again. So as you can see, the data will actually display inside the table. So here is the data inside the table, and we can go back to the database. We refresh the database. The new student will pop out, and here is the local storage for the images. So let's search for the image. It will actually be stored inside the Firebase storage. So that is completed. So the lecturer can only view the account. So they can also generate the report over here. So let's log out. And for the email address, now I want to log in as an admin. Password is admin. Now we will log in as an admin account. So we go here. You can register the lecturer. Whatever I can see. You also can view the lecture. They can perform delete or edit the lecture. That's all from the account. The main important issue is to generate the report. I will show you later. So what the main important in this system is that the lecturer can download the data inside the database here. So when they click download CSV, they will download into the student.csv file. So when they download, they can get the report of the data. So this is the most important when trying to get the feature of the anti-spoofing or other the attendance system, where we can much have a better system, and we can check if the student is attend to the class. If they scan the QR code inside the class, we don't know if they're inside the class. So we have the face recognition. We put inside the front of the class. They detect the face. They know that this student come to the class. So this make a report function is very functional and helps in actually try to help the student not to spoof the attendance of the class. So this is the main feature of the system in my PSM2. So I'll be using a black box testing for the test case for the face attendance system. So here are the tables and the test case ID. So I've done the test cases for the face recognition system with the anti-spoofing feature. I have also done the precision recall and system usability skill SAS for my project. And as you can see, here is the score for the usability score, which is 83, which is considered an excellent program or excellent project. So the future improvement for my project is that I want social network for students and lecturers implemented inside the web-based system. And the second is to have a comprehensive search feature. And the third one is to integrate a spoofing detection mechanism, which will make the system much more secure, like having a notification to the lecturers if the spoofing is detected. And the last one is to have an improved robust interface in the management system, especially in the student and the web management system. Thank you for your time, and that's for my presentation for the PSM2. I want to thank to my doctor, Dr. Noazman Ismail, for helping me in supervising my project.